talk about the order of initialization, and I'll create a separate class just for that. I'll do order of ini or whatever. And now I will create some private static int abc equals 5. And then I'll do private a, and then I'll do a couple of methods. Now I want to show you something that's called an initialization block. This is basically where you don't write any word, you just put a block here in the class and you do a equals 5, you know. So you basically, this is called before the constructor, you know. We can have the constructor, let's initialize a, and let's have a constructor private int b maybe. So let's say a equals, let's initialize both a and b to 100 for whatever reason. And then we will create a constructor which initializes a again, you know. Maybe if you use this constructor, this will be obsolete here. But if you have a constructor with no parameters, for example, then it will still call this block, you know. So this block gets called every time for every constructor, right? So it's just called an initialization block. It's used to initialize some variables, right? Maybe you want to put some default values. You could have also used something like 5 here. But again, you can use 5 here if you know the exact number. What, for example, if you need to do some calculations, you couldn't do calculations or multiple lines here. So coming up to this 5, if you don't know the exact number, but for example, A is calculated using B or C or something like that, you know, you can do something like that here. You can do, okay, A equals B math dot abs of B, something like that. So let's say A is the absolute value of B every time, whatever B is, you know. So you know, stuff like this, or I mean, even calculating plus C minus something, you know, and having multiple lines. That's when you want to use initialization in an initialization block. I'll just not overcomplicate it here. I just want to show you the order of initialization, right? We can also have a static initialization block, which is just the same thing with just the keyword static. So if I can initialize my static variables here for whatever reason, you know. I can do a plus, oh, I cannot do a, of course, because a is non-static. So, you know, a is non-static basically, which means I cannot access it from a static context. So I can do 50 here, but the other way around, it's not, I can do plus ABC here. Because basically, as we said, non-static variables can, I mean, they can access everything because they have its own copy of non-static variables and they share the copy of the classes, you know, variable, which belongs only to the whole class, right? So I can do something like this. Okay, so now I can even print something out. I mean, this is highly discouraged. You will never see this, but I just want to print out so you guys can see when we run the program, what's being initialized and so on, you know. So let's do, when this is called, I'll do a non-static init block. I'll just copy this. I'll copy it here. I'll say static init block here. At the beginning of the constructor, I'll say constructor. And here I can also say constructor. All right, cons, whatever. Okay, so now let's go ahead here and get rid of all this. Now I just want to show you what happens. Okay, but if we now do order of ini, O equals new order of ini, and we call any constructor, what's going to happen now? Well, now you can see here, basically this is what the slide says. Static blocks of the parent class, of the child class. Now we will even create some children classes of this. Basically what it's saying is all the classes that extend from this, first the parent class gets called, you know. So let me just create another class, order of ini child extends order of ini. And now it can have its own variables here. It can have like private int ABC and private static int ABCD. Doesn't really matter. And now again, it can have its own block. So we will say child, a non-static init block. We can change ABC here, of course, to whatever we want, right? In the static block, we will do child static block. And finally, I mean, here, of course, we can do ABCD equals something. We don't have to, of course, this is just fine. You don't have to change all the variables or anything. I mean, it can just be a print of something, but yeah. And let's create a constructor here, alt insert constructor. Let's do something like that. And we don't want anything. Okay, so here I'll just say s out child cons. Okay, of course, super must be the first line that you call in your constructor when you want to call it. If you don't want it at all, I mean, it's fine. But if you want to call super, it has to be the first line or you get the error. Okay, child constructor. And finally, let's do child. What did I call it? Order of init child. Order of init child. Whoops. Change. Okay. And we will pass something. And now when we run this, we can examine and we will see these results, you know. So first it calls the static initialization block. Where is that from? Well, that's from the class. So in order to create a child, it first needs to create a parent. So it first creates everything static in both of them, you know. So static initialization block of the parent, then child static initialization block. Then it calls the non-static initialization block. That's this. So basically, it's calling the constructor of the parent first. But before calling every constructor, so before even printing this line in constructor, even though that's the first thing we call, before doing that, it just chucks all of this code literally as if it's copy pasted here every time, you know. So it's literally the same having this non-static initialization block here or copying those 3 lines of code in every constructor. That's why you will never see like the same 2-3 lines in every constructor. You almost usually see like something like this, you know. So yeah, it copies that there. Then that's why it says non-static init block, because that comes from here. Then it says constructor. So basically it says constructor here, right? And now it finally goes into the child, order of init child. This is because it called the super constructor. This is why that's first. And now it says not child constructor, because it needs to, again, call its own non-static block first. So this is what it says, child non-static init block. And finally, it says child cons, because that's the last thing that it does. Okay, so again, does this make sense? This is all the possibilities. You will almost never see like both the static and the non-static initialization block and the constructor and the parent. I mean, this is the worst case scenario, you know. So you need to follow what gets called first. For example, you might not get the proper result if you initialize some variables. You thought that this was called first, but it wasn't, you know, so you might get some bug or an unexpected result somewhere. So this is, I mean, this is why you should know what gets called in what order, you know. And you can see here, you can see the child class constructor is the last thing. The previous to the last thing is its initialization block, parent constructor, and so on. It's basically what we see here, literally. Okay, does this make sense, guys, so far?